Hello, everyone. This is my first time doing a lightning talk, and I already speak very quickly, so we'll see how it goes. But my name is Danica Fine. I am a developer advocate at Snowflake, specializing in open source, so that means Apache Iceberg, Apache Polaris. We're going to focus on Iceberg today. In a past life, I was a developer advocate all around Apache Kafka, hence this wonderful synergy, this wonderful talk. And as far as the theme goes, I need a motivating, very fun theme to build my talks around. And so we've got coffee here because Iceberg, ice, coffee, Kafka. Great, right? Got it? Cool. So I'm going to assume, since this is only a 15-minute talk, I can't tell you all about what Kafka is. So I just want to know, how many of you are familiar with Kafka already? Great. For those of you who are not, or you need a refresher, it is a distributed event streaming platform. So quickly, this just enables a lot of real-time use cases, event-driven systems. So if you need more about that, we can talk later, but we're going to assume that everybody knows what Kafka is right now. But what is Iceberg? How many of you are currently working with Iceberg? No. So this is great. I'm really excited for this talk. So Iceberg, on the other hand, it's an open table format that was purpose-built to handle large-scale data sets in a data lake. How many of you have a data lake? Great. All of you are going to have one at some point. But anyway, as a technology, so at Iceberg, it exists as a way to kind of optimize for the things that we like about data warehouses. Think like the structure that we get out of that, the tabular structure, the governance, like having a single source of truth for our data. And so it combines that with the things that we like about data lakes. So once you start looking into them, you'll realize this. But the benefits of data lakes are really about having flexibility of the format of your data, like what data you're actually tossing in there. It's usually built on more cost-effective object storage, and you have the added flexibility of dealing with semi-structured and unstructured data. So, right, it's a catch-all for all of your data, right? So we're combining sort of the structure of data warehouses with the data lake, that sort of flexibility, and this is what Iceberg is. Okay, so it's an open format, so it's just telling us how to build, how to organize our files in the data lake. So anybody can build an Iceberg-compatible engine that you can use to then interact with your Iceberg tables. And so this means that Iceberg as a technology is really championing this idea of interoperability. Right? You have your data written once, you can write whatever data you want into your Iceberg tables. You have a little more structure in there, but then you can use and take that data to whatever tools that you want. This is especially useful in this, just technology is changing all the time, and the tools that you use are constantly changing. And so having that flexibility to work with whatever tools you want without doing a full migration every time is really useful. Okay. So Iceberg, it's a really great add-on to a real-time Kafka-based architecture, mostly because after you pass that initial SLA, when you're streaming data, that real-time data is only useful for a certain amount of time, beyond which you don't really need to do, rely on an event-driven structure. So offboarding that data to something like Iceberg gives you a cheaper way to maintain that data long-term, and you can run long-term analytics on top of that. All right. So it also integrates really nicely in that real-time stack. So again, since most of you are new to Iceberg, here's a quick foray into what it is. So again, it's just a format, a table format, specifying how we coordinate, how we organize, specifically this metadata layer that helps to coordinate the data files that we want to store in our Iceberg tables. All right. So you're going to look at this like Iceberg is its metadata, like it's nothing else beyond that. But you'll see here we're adding a lot of additional files into the mix in order to kind of track our data files. And so we want to be mindful as we are adding data to our Iceberg tables over time. We want to be mindful of the fact that we have a lot of files floating around, and we want to kind of minimize the number of files that we have floating around over time. So you're going to hear a lot about sort of maintenance tasks in Iceberg, where we consolidate and compact our data files as well as certain metadata files over time. Okay, so that's really important to sort of maintaining a healthy Iceberg instance over time. All right. So that's the architecture. Just to give you a little bit more context on Iceberg, here are just a few, and I really mean that, just a handful of the Iceberg-compatible compute engines that are out there available to you. On the left, we have the built-in compute engines, and by built-in, I mean that the open-source Apache Iceberg community is actively building and maintaining these two compute engines, so Spark and Flink. And on the right are just a handful, again, by no means an exhaustive list, of some of the external compute engines available to you. And so I'm just going to reiterate the fact that the benefit of moving your data to Iceberg is that we have interoperability, right? You can write your data using one of the, the built-in engines and then query it with as many number of external ones as you want, or vice versa. You have that flexibility. All right, so now, 5 minutes in, now we can talk about Kafka. So let's see what your options are for moving your Kafka data, your real-time data and Kafka topics, off into Iceberg. And you do have a few options. This is not, again, an exhaustive list, but I think these are sort of the main ones that come up when I'm talking to folks, so they're very popular here. So the first one is Apache Spark, and again, we're leaning into the coffee theme, Apache Flink, and then we could use Kafka Connect. So when I set out to actually write this talk, I was hoping that there would be just like one clear winner so that I could make this easy for you all. Like, yeah, always use this. But what I've actually seen is that these are all pretty equally weighted, and there's going to be a lot of factors that go into which one you're ultimately going to choose. And actually, depending on which side of the problem you are approaching this from the Kafka side or the Iceberg side, some of these are going to feel like more natural choices than others. So Spark and Flink, because those are the built-in supported compute engines from the Iceberg project, those are going to feel very natural to you if you're approaching this from someone who is already maintaining Iceberg tables. Yeah. On the other hand, if you're approaching it from the Kafka side, which I think a lot of you folks, are Kafka people more than Iceberg people, you're probably going to be more drawn to Apache Flink or Kafka Connect. Flink, if you're doing any sort of stream processing, you've probably dealt with Flink before, and Kafka Connect just because it's so closely tied to the Kafka project, right? And so let's get into a few more of the specifics to help guide you in your decision, because that's all I can really do is give you all the information and hopefully you make an informed choice. So for our Spark option, again, Spark is a first-class citizen from the Iceberg project's perspective. And so the biggest benefit that we get from that is that we get a lot of maintenance tasks. Remember, we want to keep track of those small files and minimize small files over time and clean up old files that are no longer referenced from your Iceberg tables. And so the biggest benefit of Spark is that we have these built-in maintenance tasks that they provide to us through Iceberg Spark actions. Okay, so you're going to need to maintain your Iceberg tables at some point. So why not have the task that is reading from Kafka and writing to Iceberg also built in Spark? That's going to save you some mental cycles and reduce, you don't have to add another technology to your stack, right? So that would be one thing to consider there. So Spark, because it is sort of the reference implementation for all of the other engines that are Iceberg compatible, it has all of the supported table operations that you would want and more. So write, insert, merge, append. Overwrite is kind of a bonus one that we get out of there. And this is where you can completely replace an entire partition's worth of data at a time within your Iceberg table. And this might be useful if you're using, say, compact topics quite a bit. I think that that's really one of the biggest use cases that I would pull that in for. Upserts, that is actually a limitation on Spark's part. You can do them, but it's kind of a workaround where you have to use 4 each. There's a temporary table in there, and you have to remember to clean things up in your catalog. So you can do upserts, but you might not want to, depending on how much effort you want to put into the program. One other thing, so in Iceberg, when we're thinking about deleting data, there's 2 types of deletions. There is an equality delete and a position delete. Position deletes are very specific. They say, from this file in Iceberg, we are going to remove or ignore the row at this index. It should be deleted. We don't care about it anymore. Equality deletes are more general. They say, if this certain if we match this certain field anywhere in this row, or for this specific field, it has this value, we are going to ignore it, okay, earlier than a certain timestamp. So it can apply across multiple data files and potentially reach multiple rows. Equality deletes, some people say they're really useful in streaming. I'm not so sure. The reality is that equality deletes were only introduced by the Flink community when they were building out the implementation for the compute engine. And so, as such, Spark does not handle them. All right, so if you need equality deletes, if you're really relying on those, sorry, you can't use them in Spark. So getting into sort of the streaming approach of this, like if you're using Kafka, you're familiar with streaming, Spark is not streaming. I'm sorry. We say sometimes people claim that it is streaming. It is microbatching. And so just something to keep in mind if you have certain SLAs for offboarding your data from Kafka into Iceberg, you'll have to decide for yourself if that's actually a concern. Okay. And a bonus for all of these options that I have to bring up is that there's an additional mode called fast append. So with all of those metadata files that we have to write and maintain in Iceberg every time we write data to that table, fast append minimizes the number of write operations that we have to do, or the number of files that we have to touch. Okay, so that's something that all of these have the option to do. All right, for Flink, another obvious win here is that, yes, it's a supported engine from the Iceberg project. So the way that you interact with your tables is you do it natively using an Iceberg connector. So for the Kafka Flink Iceberg pipeline, you write a Flink job with your Kafka source. The bonus is that you can do some real stream processing in there, and then you offboard it using an Iceberg sync. There are actually two Iceberg syncs from the Flink project. One is the horribly named Flink sync. I don't know why they called it that. And now the new one is called an Iceberg sync, and it's built on the V2 Flink sync abstraction. So we get some cool things for free, like exactly once. Who doesn't love that? Small file compaction. It does that to a degree automatically for you. You have that flexibility. And there's also talks of having that built-in maintenance functions like we have in Spark. But keep an eye out for that. Okay, and again, we have fast append. For Kafka Connect, so this is a relatively new part of the Iceberg project. It was recently donated by the folks from Tabular. So keep that in mind. It's relatively young when you think about it being part of the open source project. The architecture is pretty cool. It uses a centralized commit model where it reads from, aggregates data from multiple partitions from that Kafka topic, holds it for a period of time, and does kind of a batch write to sort of minimize the amount of small files that we're adding to our Iceberg table. It's really similar to if you're doing any sort of batching with your Kafka producers. Okay. There's still going to be, trade-off on actually holding that data. Then you're going to, affect your latency. So you'll have to ask yourself if that's worth it. You will still have to do some maintenance because there are no maintenance functions built in from the Kafka connector. Okay. But outside of that, we get exactly once. You have SMTs to sort of do some minimal transformations if you need to, and that might get you far enough. Okay, and then again, we have fast append mode. All right, so that was a lot of information. We have 3 minutes left. How do you actually decide? And so I'm going to go through here. There's some additional information that I'm tossing in here, so you might want to get a photo at the end when we have all of these up. And I just want to kind of summarize here. So the situation where I think you might want to use Spark for this is if that, okay, you and your team are the Kafka people, right? You are working with your Kafka data. Maybe you own the Kafka cluster. And ideally, in the ideal world, there's a separate team maintaining your Iceberg tables, right? And you have just been asked to pretty please make this data available to them so that they can ingest it into Iceberg tables. In that case, they don't really care about streaming, level latency, right? They can take their time to ingest the data. They're already familiar with Spark. They're just going to, feed your Kafka topics into a Spark job and write that into Iceberg for you. And then they are also familiar with Spark to the degree that they can run the maintenance tasks on their end. So it's really, Spark would be ideal if it's coming from, that sort of separated situation. When you would use Flink, if your team is already running Flink jobs, right? You already are familiar with and are running those stream processing jobs in Flink. You don't want to, I wouldn't recommend adding an additional technology into your stack if you don't need to. You would also maybe want to use Flink if you have some additional stream processing that you need to do before you offboard that data into Iceberg. And again, ideal situation, somebody else is maintaining those tables for you so that you are not hard-pressed to maintain those tables via Spark, and throw something else into your stack as well. And then for Kafka Connect, I'd really, again, we have this sort of separation. I think that Kafka Connect is just the easiest way to get started, honestly, because if you're already approaching this from the Kafka situation where you're familiar with, you're probably already using Kafka Connect for other areas, for other applications, this is just going to be the easiest way for you to offboard data into Iceberg, okay, just to get started. Pretty good on the configurations that are available to you. The biggest con is that you don't have any option to do any sort of maintenance on there at all. But again, in that ideal world, there's somebody else that's maintaining your Iceberg tables for you so that you don't have to think about it. Otherwise, you will have to have some brave soul on your team to run those maintenance tasks through Spark. Okay, so that is your quick survey. I know I've got 30 seconds left, and I can put that slide back up for those of you. But I just want to close out with, I have a link to my link tree here. So I have a number of resources, both from the Kafka Kafka side, mostly from the Iceberg side these days. But if you are curious to hear more about Iceberg, the best resource that I just posted up there is that we recently had Iceberg Summit a couple weeks ago. And all of the session recordings are available on YouTube, so that link is up there. And I would really encourage you to peruse that if you are interested in hearing more about that technology. And so, with that, 1 second left. Oh my gosh, I made it. Okay, cool. Thank you all, and I will take some questions if we have time.